Part 1. The beginning, more than just digital money. Let me tell you a story about a kid named Vitalik. In 2011, when Vitalik Buterin was just 17, his father introduced him to this strange new thing called Bitcoin. Like many of us first hearing about it, he was skeptical. Why would digital money have any value? He wondered. But unlike most of us, he didn't just shrug and move on. He dug deeper. Vitalik started writing articles about Bitcoin for a blog, earning 5 BTC per article, about $4 at the time, worth nearly $350,000 at Bitcoin's peak. The more he learned, the more fascinated he became. But he also started noticing Bitcoin's limitations. It was like a calculator that could only do one thing really well: send value from point A to point B. Meanwhile, in the real world, Vitalik was playing World of Warcraft. One day, Blizzard removed his favorite warlock spell. "I cried myself to sleep," he later said. More importantly, he realized something profound. When you play on someone else's server, they make the rules. They can change the game whenever they want. These two experiences converged in his mind. What if we could create a system that wasn't just about money but about rules? What if we could build applications that no single entity controlled? What if we could create a world where the rules couldn't be changed arbitrarily, even by their creators? This was the seed that grew into Ethereum. Part 2. The big idea, not an app but an app store. Let's start with what Ethereum isn't. It's not Bitcoin 2.0. It's not just another cryptocurrency. The easiest way to understand Ethereum is to think of it as a global, decentralized computer. Imagine if your smartphone could only run one app. That was Bitcoin. Now imagine if someone built an app store into the blockchain itself. That's Ethereum. Here's the revolutionary idea. While Bitcoin's blockchain records financial transactions, Alice sent Bob 1 BTC, Ethereum's blockchain can run computer programs. These aren't normal programs though. They run exactly as written, they're visible to everyone, and once deployed, no one can change them. These programs are called smart contracts, a terrible name because they're not really smart, and they're not really contracts in the traditional sense. They're more like vending machines. Think about a vending machine. You put in $2, press B12, and out comes a bag of chips. The rules are baked into the machine. $2 plus B12 equals chips. No human decides whether you get your chips. The machine just executes the code. Now imagine a vending machine that could sell not just chips but insurance policies, domain names, voting rights, or even pieces of a Picasso painting. And imagine this vending machine exists everywhere and nowhere simultaneously, maintained by thousands of computers worldwide. That's closer to what Ethereum enables. Part 3. The fuel, ether and gas. If Ethereum is a global computer, it needs fuel to run. That's where ETH comes in. People often confuse Ethereum, the platform, with Ether, the cryptocurrency, but they're different things, just like how the internet isn't the same as PayPal. When you want to run a program on this world computer, you pay for the computation in Ether. But here's the clever part. You don't pay per minute or per operation. You pay per computational step. Each operation, adding numbers, storing data, etc., has a tiny cost measured in gas. Why gas? Because just like your car needs gas to drive, smart contracts need gas to execute. And just like gas prices fluctuate, the cost of computation on Ethereum fluctuates based on network demand. This serves two crucial purposes. 1. It prevents infinite loops. If you run out of gas, the program stops. 2. It pays the people who provide the computational power, miners and now validators. So when someone says, gas fees are high today, they mean it's expensive to run programs on Ethereum because the network is busy. It's like surge pricing on Uber during rush hour. Part 4. The virtual machine, Ethereum's heart. At the core of Ethereum is the Ethereum Virtual Machine, EVM. Think of it as the processor of our world computer. But unlike your laptop's processor, the EVM runs on thousands of computers simultaneously. Here's the magic. Every Ethereum node, participant in the network, runs the EVM. When a smart contract executes, it doesn't run on one computer, it runs on all of them, and they all must agree on the result. This is what makes Ethereum decentralized and tamper-proof. The EVM is also Turing-complete. This computer science term simply means it can perform any computation that any other computer can, given enough time and resources. Bitcoin's scripting language is intentionally limited. Ethereum's is not. This is both its superpower and its vulnerability, as we'll see. Part 5. Decentralization, the core philosophy. To understand why Ethereum matters, you need to understand decentralization. We're so used to centralized systems that we barely notice them anymore. Your money? In banks, centralized. Your emails? On Google's servers, centralized. Your social media? Controlled by Meta, Twitter, etc., centralized. Your medical records? In hospital databases, centralized. Centralization creates single points of failure. It creates gatekeepers. It creates censorship risk. Remember Vitalik's World of Warcraft spell? That's a tiny example of centralized control. Ethereum offers an alternative: trust minimization. You don't need to trust a person or company, you just need to trust that the code will execute as written. And since thousands of independent computers are verifying this execution, you can be reasonably certain it will. This isn't about eliminating trust entirely, you still need to trust the code was written correctly. It's about reducing the number of parties you need to trust from many fallible humans to mathematics and cryptography. Part 6. The DAO Hack, a Painful Lesson. In 2016, Ethereum faced its first major crisis. A decentralized autonomous organization called the DAO raised $150 million in Ether, at the time, about 14% of all ETH in existence. The DAO was meant to be a venture capital fund governed by token holders. But there was a bug in the code. Someone found it and began draining Ether from the DAO. Because of how Ethereum works, everyone could see it happening but no one could stop it. The code was executing exactly as written. The community faced an impossible choice. 1. Do nothing and let the hacker keep $50 million worth of ETH. 2. Fork Ethereum to reverse the theft, violating the code is law principle. After intense debate, they chose option 2. Ethereum split into two chains, Ethereum, which reversed the hack, and Ethereum Classic, which didn't. This was Ethereum's constitutional crisis. It revealed that immutable code isn't so immutable when humans decide to change it. But it also taught valuable lessons about auditing code, writing secure smart contracts, and the reality that decentralization involves human communities, not just technology. Part 7. The ICO boom building on Ethereum. Despite the DAO hack, developers flocked to Ethereum. Why? Because for the first time they could create tokens without building their own blockchain. With just a few lines of code, anyone could create a token on Ethereum. This led to the initial coin offering ICO boom of 2017. Projects raised billions by selling tokens before they'd built anything. Most ICOs were scams or failures. But some legitimate projects emerged. Chainlink brings real-world data onto the blockchain. MakerDAO created the first decentralized stablecoin DAI. Uniswap revolutionized trading with automated market makers. The ICO craze revealed both Ethereum's potential and its problems. Yes, it was incredibly easy to launch tokens. But it also created a wild west of speculation. And as more people used Ethereum, the network slowed down and fees skyrocketed. Part 8. Scaling Problems, the Blockchain Trilemma. Ethereum co-founder Vitalik Buterin describes the blockchain trilemma. You can only optimize for two of these three properties. 1. Decentralization, many participants. 2. Security, resistant to attack. 3. Scalability, handles many transactions. Bitcoin prioritizes decentralization and security. Ethereum originally prioritized decentralization and security. But as Ethereum grew, the lack of scalability became painful. The original Ethereum could handle about 15 transactions per second. Visa handles 65,000. When CryptoKitties, a game where you breed digital cats, went viral in 2017, it literally clogged the entire Ethereum network. This was clearly unsustainable. Ethereum needed to grow up. It needed to scale. Part 9. The Road to Ethereum 2.0, a 5-year journey. In 2020, Ethereum began its most ambitious upgrade, Ethereum 2.0, now called the consensus layer. This wasn't a simple update, it was like replacing a plane's engines while flying. The key changes. 1. Proof of Stake, September 2022. Ethereum moved from proof of work, miners solving puzzles, to proof of stake, validators staking ETH. This reduced energy consumption by 99.95%. Instead of competing to solve puzzles, validators are randomly selected to propose blocks based on how much ETH they've staked as collateral. 2. Sharding coming. Imagine a library where everyone has to wait in line for one librarian. Sharding is like hiring 64 librarians, each handling their own section. The blockchain splits into shards that process transactions in parallel. 3. The merge. This was the moment when Ethereum's original chain, proof of work, merged with the new proof of stake chain. It was one of the most technically complex upgrades in software history, and it worked flawlessly. These upgrades aim to eventually handle 100,000 transactions per second while maintaining decentralization and security. Part 10. DeFi, the Financial Revolution. The most significant development on Ethereum has been decentralized finance, DeFi. Think of it as rebuilding Wall Street with open-source code instead of banks. Traditional finance has intermediaries everywhere. Want a loan? Talk to a bank. Want to trade stocks? Use a broker. Want to earn interest? Open a savings account. DeFi replaces intermediaries with smart contracts. Compound, get a loan by depositing collateral. Uniswap, trade tokens directly with a liquidity pool. Aave, earn interest on your crypto. The numbers are staggering. From virtually zero in 2019, DeFi grew to over $100 billion locked in smart contracts by 2021. And it's global. Someone in Venezuela can access the same financial services as someone in New York. But DeFi has risks: smart contract bugs, regulatory uncertainty, and the complexity that has led to billions in user errors. It's the Wild West of finance, for better and worse. Part 11. NFTs more than monkey pictures. Non-fungible tokens, NFTs, exploded in 2021, with Bored Ape Yacht Club and CryptoPunks selling for millions. Critics called it a scam. Supporters called it the future of digital ownership. But NFTs are more than expensive JPGs. At their core, NFTs are provably unique digital items on the blockchain. This simple concept has profound implications. Digital art, artists can sell directly to collectors with automatic royalties. Gaming, true ownership of in-game items across different games. Music, musicians can sell special editions with unique perks. Identity, digital credentials that can't be forged. Real estate, fractional ownership of physical assets. The NFT boom revealed something important: people value digital ownership. And Ethereum provides the infrastructure for that ownership to be verifiable and transferable without intermediaries. Part 12. DAOs, new ways to organize. Decentralized autonomous organizations, DAOs, are perhaps Ethereum's most radical application. A DAO is an organization run by code rather than people. Members hold tokens that represent voting shares. Proposals are made and voted on-chain. If a proposal passes, it can automatically execute, like transferring funds from the DAO treasury. Examples: Constitution DAO raised $47 million in days to buy a copy of the U.S. Constitution. They lost the auction. Uniswap DAO governs the Uniswap protocol with billions in treasury. City DAO, buying and developing real land through decentralized governance. DAOs are messy, inefficient, and revolutionary. They represent an experiment in human coordination at scale without central leadership. Part 13. The Layer 2 explosion. As Ethereum struggled with high fees, Layer 2 solutions emerged. Think of these as express lanes on the blockchain highway. Optimistic rollups and ZK rollups bundle thousands of transactions off-chain, then post a summary to Ethereum. This reduces fees by 10-100x while maintaining Ethereum's security. The most successful Layer 2, Arbitrum, processes more transactions than Ethereum itself. This represents a fundamental shift, Ethereum becoming a settlement layer like a Supreme Court, while Layer 2s handle everyday transactions like local courts. Part 14. The competitors. Ethereum isn't alone. Ethereum killers have emerged, each with different approaches. Solana prioritizes speed, 65,000 TPS, but has faced reliability issues. Cardano takes a slow, academic approach to development. Polkadot connects multiple specialized blockchains. Avalanche focuses on fast finality and custom blockchains. Each makes different trade-offs in the trilemma. But Ethereum's first-mover advantage, network effects, and robust developer community have kept it dominant despite higher fees. Part 15. The regulatory battlefield. As Ethereum grew, it attracted regulatory attention. The key question: is ETH a security? If it is, Ethereum would face massive regulatory burdens. The SEC's Gary Gensler believes most cryptocurrencies, except Bitcoin, are securities. Ethereum supporters argue it's a commodity like gold or wheat, or even a new asset class. This isn't just legal semantics. How Ethereum is classified will determine whether it can grow freely or becomes constrained by securities regulations designed for traditional markets. Part 16. The social layer. What's often missed about Ethereum is its social dimension. Ethereum isn't just technology, it's a movement. Thousands of developers worldwide contribute to Ethereum for ideological reasons. Belief in open systems, distrust of centralized power, desire for financial inclusion. The Ethereum community includes the cypherpunks who value privacy above all, the Regans focused on public goods funding, the Degans chasing the next 100x yield farm, the institutional players bringing traditional finance on-chain. This diversity creates tension but also resilience. Unlike corporate projects, no one person controls Ethereum's direction. It evolves through rough consensus and running code. Part 17, Real-world use cases beyond speculation. Beyond DeFi and NFTs, Ethereum is enabling practical applications. 1. Supply chain. Companies like IBM use Ethereum to track goods from farm to table. Each step is recorded on-chain, creating an immutable audit trail. 2. Identity. 3 billion people lack official identification. Ethereum-based systems like Civic allow self-sovereign identity. You control your digital identity without relying on governments. 3. Voting. Countries like Estonia are experimenting with blockchain voting. While technical challenges remain, the potential for verifiable, tamper-proof elections is compelling. 4. Content moderation. Platforms like Mirror allow writers to publish without censorship. Once something is on Ethereum, it can't be removed, which creates its own problems. 5. Carbon credits. Toucan Protocol tokenizes carbon credits, creating transparent markets for climate action. Part 18. The challenges, not all roses. Ethereum faces significant challenges. 1. User experience. Using Ethereum is still too hard. Seed phrases, gas fees, failed transactions. It's not for the faint of heart. Mainstream adoption requires interfaces as simple as Instagram. 2. Centralization pressures. Despite decentralization ideals, reality creeps in. Most Ethereum nodes run on Amazon Web Services. A few companies control major wallet software. Large stakeholders could potentially influence the network. 3. MEV miner/validator extractable value. Validators can reorder transactions to extract value, creating what's essentially front-running on the blockchain itself. 4. Regulatory risk. As mentioned, uncertain regulation hangs over Ethereum like a sword of Damocles. 5. Environmental concerns. While proof-of-stake reduced energy use dramatically, critics still point to Ethereum's carbon footprint during its proof-of-work years and ongoing electronic waste from hardware. Part 19. The philosophy, why it matters. At its heart, Ethereum represents a philosophical stance. Trust should be verifiable, not given. In a world of fake news, financial crises, and institutional distrust, Ethereum offers an alternative. Systems where the rules are transparent and enforcement is automatic. It's not about removing humans but about creating systems where human failure causes less damage. This isn't just about money. It's about transparency in organizations, access to global systems, ownership of digital creations, coordination across borders. Ethereum is an experiment in whether we can build systems that are robust, open, and fair by design rather than by the goodwill of those in power. Part 20. The future, what's next? Where is Ethereum headed? 1. The Surge 2023 to 2024. Implementing proto-danksharding to dramatically reduce Layer 2 costs, potentially making transactions cents instead of dollars. 2. The Scourge 2024 to 2025. Addressing MEV and centralization risks to ensure fair and accessible transactions. 3. The Verge 2025 to 2026. Implementing Verkle trees to allow nodes to operate with less storage, improving decentralization. 4. The Purge 2026 to 2027. Simplifying the protocol by removing historical data, reducing technical debt. 5. The Splurge Beyond. Various other upgrades to optimize performance. Beyond technical upgrades, Ethereum's future depends on adoption. Will mainstream users embrace decentralized apps? Regulation. Will governments enable or stifle innovation? Competition. Can Ethereum maintain its lead against faster, cheaper alternatives? Innovation. What unforeseen applications will developers build? Conclusion. The unfinished cathedral. Ethereum is often compared to the early internet. In 1995, people asked, why do I need email when I have fax? Today we ask, why do I need DeFi when I have banks? Like the early internet, Ethereum is clunky, confusing, and full of scams. And like the early internet, it has the potential to reshape society. But here's the crucial difference. The internet started as decentralized, anyone could create a website, but became centralized. Google, Facebook, Amazon dominate. Ethereum is trying to build systems that stay decentralized. Will it work? No one knows. Ethereum is an experiment with billions of dollars and millions of people participating. It might fail spectacularly. It might become the foundation of our digital lives. What's certain is that Ethereum has already changed how we think about trust, ownership, and organization. It has inspired thousands of developers to build a different kind of internet. It has given people in unstable economies access to stable money. It has created new forms of art and community. Ethereum isn't just technology. It's a question: can we build systems that are open, neutral, and resilient? Can we create a digital world that serves everyone, not just platforms? The cathedral is unfinished. The builders are still working. The blueprint keeps evolving. But the foundation is laid, and it's stronger than many realize. Whether Ethereum succeeds or fails, it has already taught us something important. We can imagine different systems. We can build alternatives. The digital world doesn't have to belong to corporations. We can create systems that are, in their own imperfect way, more fair, more open, and more human. That might be Ethereum's most lasting contribution. Not the technology itself, but the reawakening of the belief that we can build better systems together.